Good morning, students. This is Pavan Kumar, lecturer in electronics, MVNJS and RPI College, Malkipuram. In this video, I have to discuss types of logic gates and its operation and advantages and disadvantages of the logic gates. This video is belongs to second B.Sc electronics students in semester 3. So let us go for in this video lecture, I have to discuss what are the types of logic gates and applications of logic gates, advantages and disadvantages of logic gates. First, we have to idea about what is the logic and what is meant by Boolean function. So logic is depends upon the which type of gates you have to use in the combination of logic logic variables. So we have to discuss what is meant by logic gate. A logic gate is a physical electronic device implementing a Boolean function. So logic gates are used for implementing the Boolean functions. So what is meant by Boolean function? Boolean function is a combination of variables which are logically added or ended depending upon the where which type of logic you have to use. You know about the logic, R logic, N logic, and not logics are the basic logics for using in digital electronics. So these are the Boolean functions. Logic gates are building blocks of any digital system. Yes, these are the building blocks of the digital systems. It is an electronic circuit having one or more than one input and only one output. The basic digital circuit or logic gates have only one output but two or more inputs. The relationship between input and output is based on certain logic. The logic is depends upon the combination of input and same as well as which type of logic we have to use in a certain logic. The based on this logic gates are named as AND gate and OR gate and NOT gate. The logic gates are divided into depending upon the which type of logic we have to use, like OR logic, AND logic, and NOT logic. Now, logic gates are primary implemented using diodes or transistors acting as a electronic switches. Primarily you have to use logic gates like electronic switches for on and off purpose and diodes and forward bias and reverse bias and either transistor acts as a three region operating conditions like active region and cutoff region and saturation region. These are the primary used for logic gates in different devices. Logic circuits include such devices as multiplexers, registers, arithmetic logic units, ALUs, and computer memory microprocessors, which may contain more than 100 million gates. Logic gates so you have to inbuilt some devices like multiplexer. Multiplexer means many to one function. That means we have to use many inputs that are connected with a single output. These are the multiplexers and registers. Register is a storage memory. We have to use a number of logic gates for storing the information in the form of bits. That is a flip-flop. Flip-flop is a one-bit memory element which is used to store the one-bit memory of binary information. And arithmetic logic units. You know about the ALU operations, and operation, R operation, and logical not operations are you have to use in the ALU. And all arithmetic and logical operations are you have to perform by based on these logic gates and computers memory and rom and ram memory based devices are fabricated by using these logic gates and microprocessor chips. You have to look at the figures. The microprocessor chips are made for the basic logic gates, which may contain more than 100 million gates. You have to use the microprocessor chips. So now types of logic gates. You have to divide seven logic gates here: OR gate, AND gate, XOR gate, NOT gate, NOR gate, NAND gate, and XNOR gate. These are the types of logic gates. First, we have to discuss what is meant by OR gate. OR gate is a logic gate which is used to perform logical OR operation. What is meant by logical OR operation? You have to use two different operations like addition and multiplications in digital electronics. Depending upon these logics, either OR logic or AND logic, you have to use a certain logic by using these gates is called a OR logic. The logical symbol of the two input OR gate is as shown in below. Look at the symbol of OR logic. You have to, in this symbol, you have to only two variables and only one output. We have already discussed a logic gate is a one or more inputs and only one output. The above OR gate has two inputs, they are A and B input variables, and Q is the output variable. The Boolean expression of the OR gate Q equal to A plus B. Here we can observe the Boolean expression or Boolean function Q equal to A plus B. Here A and B are the two binary variables used for input, and plus is the our set our logic. That means plus is our logic. We logically added two variables, which is equal to Boolean expression or Boolean function. These are the OR gate. You have to use add two binary numbers like A and B, which are used to OR gate. You have to look at the truth table with respect to the symbol of the OR gate. These are the truth table shows the what are the combination of we have to use the two binary numbers. Two for n is the possible conditions we have to use in binary number system in decimal in digital electronics. 2 for n. 2 is the base of the number system. That means binary number system base is 2 and n is the number of variables. We have to use the per input variables. Here we have to use two input variables a and b. So 2 for n equal to 2 for 2 which is equal to 4. So that's why you have to use two binary numbers in four combinations A and B. First combination 0 0. So output Q equal to A plus B. You know about the you can see the right side binary addition. Binary addition have four rules: 0 plus 1, 0 plus 0 equal to 0, and 0 plus 1 equal to 1, and 1 plus 0 equal to 1, 1 plus 1 equal to 1. These are the basic binary addition rules we have to use for this logical OR operation. So first we have to add 0 plus 0 which is equal to output Q equal to 0. And second condition, if B equal to 0, A equal to 1, then B plus C, 0 plus 1 equal to 1. And third condition, 1 plus 0 which is equal to 1. And fourth condition, 1 plus 1 equal to 1. These output is depends upon the combination of inputs as well as which type of logic you have to use by using this logic OR operation. if the output is high when one or both inputs are high. Look at this logic. What is the or logic? If output is high when or one or both inputs are high. If neither input is low, then output is low. These are the logic or logic depending upon the truth table. Next, AND gate. AND gate is a logic gate which performs binary multiplication and logical AND operation, which is depends upon the binary multiplication. The logic symbol of the two input AND gate is shown below. Look at the symbol here. Here you are using only two binary variables like A and B, and output key equal to A dot B. That is the multiplication logic. Here in this gate, we have to Boolean expression or Boolean function q equal to A dot B. Look at the truth table. In this logic, we have to use four combinations based on the zeros and ones. The output q equal to A dot B. You know about the binary multiplication. 0 dot 0 equal to 0 and 0 dot 1 equal to 1 and 1 dot 0 equal to 1 and finally 1 dot 1 equal to 1. These are the binary multiplication rules. Based upon these rules, we have to use AND operation. Q equal to A dot B. First we have to multiply first two digits. 0 dot 0 equal to 0. 0 dot 1 equal to 0 and third condition 1 dot 0 equal to 0 and finally 1 dot 1 equal to 1. This is the truth table for 2-bit AND gate. That means two input AND gate. In logic and operation, if the output is high when both inputs are high. This is the logic. If output is high when both inputs are high. If neither input is low, then output is low. If that means if neither input is low, then output is low is shown in above truth table. NOT gate. A NOT gate is a logic gate that performs logic NOT operation. A logic gate, a NOT gate is a single input NOT gate. That is another name of the NOT gate is inverter. Inverter is a NOT gate. It has only one single input and only one output. The, the logic symbol of the NOT gate as shown in below. In this symbol, we have to use only input variable A and output key equal to A bar. A bar means complement of A. If the input is A and output will be negated A. Negated means complement of A. Look at the truth table. Here only one input A, which is either 0 or 1, then output key equal to A bar. A, if A equal to 0, then Q equal to A bar. That means 1 bar. I mean 0 bar, which is equal to 1. And if A equal to 1, then output equal to 0. Depending upon the Boolean laws, we have to look at the first law. This is the AND law, I mean R law. A plus A bar equal to 1. And AND law A dot A bar equal to 0. We have to verify if A equal to 0, first law we have to verify if A equal to 0, then 0 plus 0 bar equal to 1. That means 0 plus 0 1 means 1 bar 1, 0 plus 1 equal to 1. And we have to verify second law AND law. A dot A bar equal to 0. We have to put A value 0, then A dot 0 dot 0 bar equal to 0. In other case, if A equal to 0, then A equal to a plus a bar equal to 1. In this equation, a equal to 1 plus 1 bar equal to 1. And second and law, 1 dot a bar equal to 0. In this equation, we have to put a equal to 1, then 1 dot 1 bar equal to 0. These are the not Boolean laws. In this, we have to use complement of a binary numbers. Next, NOR gate. A NOR gate is a logic gate performs logical NOT operation. So, NOR gate is a basic NOR gate is a logic gate which performs logical NOT operation. We have to look at the symbol. These are the two input NOR gate and only one output. The Boolean expression of the NOR gate Q equal to A plus B whole bar. In previous section, we have to discuss on OR logic A plus B. In this gate, NOR gate, we are adding two gates here, NOT gate plus OR gate. NOT gate plus OR gate is adding to two input A and B and output Q equal to A plus B whole bar. A plus B whole bar which is equal to NOR operation. That means you have to look at the table. In previous OR gate, we have to add two binary digits in four combinations like 0 plus 0 equal to 0 and 0 plus 1 equal to 1 and 1 plus 0 equal to 1 and 1 plus 1 equal to 0. In this binary addition, we have to require complement of these numbers, that means a plus b whole bar. That means negated OR gate. So you have to use two variables in four combinations 0 plus 0 equal to 1, actually 0. So in this symbol the Boolean expression a plus b whole bar, hence 0 plus 0 0 which is 0 bar equal to 1 negated OR gate. So remaining for three conditions are the same as this from a plus b whole bar. If the output is high when one or both inputs are low. If output is high when one or both inputs are low. If neither input is high, then output is low. This is the NOR logic. And next we have to discuss NAND logic. And NAND logic is a logic gate that performs logical NOT and AND operation. This gate also combination of two gates and AND gate and NOT gate. Look at the symbol of the AND gate. We are using only two inputs A and B and get only one output Q equal to A dot B whole bar. In previous section we have to discuss AND gate operation A dot B and NOT gate operation and inverter operation. The combination of NOT gate and AND gate form a NAND gate. So output expression or Boolean expression of the NAND gate is Q equal to A dot B whole bar. Look at the truth table. In this truth table, we have also used two variables and four combinations. In this logic, we are using only binary multiplication because we are using AND gate operation A dot B. So we have to use four combinations like 0 dot 0 equal to 0, 0 dot 1 equal to 1, and 1 dot 0 equal to 1, and 1 dot 1 equal to 1. Using these binary multiplication values, you have to use and simplify the Boolean expression Q equal to A dot B whole bar. A dot B whole bar which is equal to, we have to use first condition 0 dot 0 whole bar. 0 dot 0 is equal to 0, 0 bar equal to 1. So the output will be Q equal to 1. And second condition, B equal to 0, A equal to 1 and output key equal to a dot b whole bar. 1 dot 0 whole bar equal to 1 dot 0 means 0, 0 bar equal to 1. Like this, they are the four conditions for NAND operation depending upon the binary multiplication. A logical AND operation. If the output is Q is high, that means 1 when both inputs are low. If neither input is high, then output is low. This is the NAND logic. And next one, XOR gate. Exclusive OR gate, which means the XOR gate. An XOR gate is a logic gate that performs logical X operation. I mean XOR operation. That means the XOR operation is A plus circle B. Plus circle represents the XOR operation. Look at the symbol of the XOR gate, two input XOR gate. A and B are the two input variables and output Q equal to A plus circle B. The Boolean expression of the exclusive OR gate A Q equal to A plus circle B. That means AB bar plus BA bar. A plus circle B, which is equal to AB bar plus BA bar. Now look at the truth table. We have to use Q equal to A plus circle B whole bar. I mean Q equal to A plus circle B. So which is we have to verify by using AB bar plus BA bar equation, which is equal to A plus circle B. So if A equal to 1 and B equal to 1, I have to verify the last condition, A value A equal to 1 and B equal to 1. Then we get AQ equal to A plus circle B. So which is equal to AB bar plus BA bar. We have to put the A value and B value both serve 1. 1 dot 1 bar plus 1 dot 1 bar, which is equal to 1 dot 0 plus 1 dot 0, which is equal to 0 plus 0, and we get Q equal to 0 in fourth condition. We have to use these four combinations like this. You get a truth table values Q equal to A plus circle B, which is a XOR gate operation. If the output is high 1 when one of the input is 1. If both inputs are low or high, then output is low. If both inputs are low or high, then output will be low. This is the exclusive OR logic. And finally, XNOR logic. This is a combination of NOT gate and exclusive OR gate. An XOR gate is a logic gate that performs logical NOT XOR operations. The logical symbol of two input XNOR gate is shown below. In this symbol, we have to use two binary variables A and B are the inputs, and we get only one output Q, which is equal to A plus circle B whole bar. The is complement of XOR gate. Q equal to A plus circle B whole bar, which is equal to, we know about the A plus circle B in previous condition, in previous gate, A dot B whole bar plus B dot A bar whole bar, which is a complement of XOR gate. Look at the table. We have to use two variables. That means we have to convert these two variables in four combinations. The output Q equal to A plus circle B whole bar. So Q equal to 0 plus circle 0 whole bar, which is equal to 1. 0 plus circle 1 whole bar, which is equal to 0. And 1 plus circle 0, which is equal to 0. And 1 plus circle 1, which is equal to 1. These are the four logic conditions we have to use in XNOR gate. The Boolean expression or Boolean function Q equal to A plus circle B whole bar. which is equal to AB bar plus BA bar whole bar. These are the overall gates. Now let us discuss what is the applications of logic gates. So look at the some point list out here. Burgle alarms and buzzers. The applications of logic gates, burglar alarms and buzzers, computation and processing circuits, and push button switches. Example, doorbell. Functioning of state lines, data transfer function, and TTL. TTL is a logic family, transistor logic, and CMOS circuitry. CMOS means complementary metal oxide semiconductor circuitry. These are the some important applications and daily life you have to use daily life in by using logic gates. Advantages of logic gates. The advantages of logic gates are operations are performed using Boolean algebra, which makes the circuit design more economical and simple. We have to use the later we have to discuss so what are the types of logic gates, which type of logic you have to use for suitable applications. If we have to design any digital circuit or any digital device logic, you have to design the economical and the simple and easy to very easy to simple, because you have to use only two binary digits like 0 and 1. That means you have to easy to implement or design the logic in our certain economical laws. Logic 1 and logic 0 can be easily distinguished. That means that our shifting process or manipulation or have to convert, you have to inverted or that means negated is easily to move from 1 and 0. These are the main advantages of the logic gates. And disadvantages are also to some point out here. Operating voltage is limited. Time delay occurs between input and output. Operating voltage. You have to look at the graph. Operating voltage and inverter. Red color indicates the inverter and NAND gate indicates blue color and green, which is in the NOR gate. Operating dependent on the below 0.25 volts and up to 1.25 volts. And then so also time delay occurs using these logic gates. The other disadvantage is time delay between input and output. If we have to use, we have to look at the graph time delay, voltage versus time. Is high, then output voltage will be towards the zero. This taken some time delay. The time delays disadvantages of the logical gates. This is the thank you. This is the final overall discussion of what is the types of logic gates and applications of logic gates and advantages and disadvantages. You have to use these logic gates. You have to simplify and design Boolean Boolean expressions by using Boolean laws. These are the types of logic gates. So thank you.